In December 2024, Google's quantum AI division switched on a machine called Willow.
Google's Willow chip is touted as not just another technology breakthrough, but an evolution in the way we solve some of the world's toughest challenges.
And its own lead physicist, Hartmut Neven, offered an explanation for how it works that most scientists would never dare say out loud. This isn't the AI you're picturing. No chatbot, no typed answers. It's a 105-qubit quantum computer that solved in under 5 minutes a problem an ordinary supercomputer couldn't finish in the lifetime of the universe.
The idea is that Willow might be communicating with parallel universes to finish calculations faster.
And when Neven asked where all that computing power was actually coming from, his answer pointed somewhere so strange, it reopened the oldest question we have about reality itself. The dream of an impossible machine. Here is the first thing you need to know, because the title probably already has you half confused. Neven runs a division inside Google. Its actual name is Google Quantum AI. So, when you hear quantum AI, slow down. This is not the AI you are picturing. No chatbot. Nothing typing sentences back at you. The machine at the center of this doesn't think in words at all. It doesn't run on language, and it doesn't obey the rules of any computer that has ever existed. Hold on to that, because it's the whole reason what Neven saw hit him so hard. For decades, scientists chased a dream. A computer so powerful, so fundamentally different from anything ever built, that it wouldn't just run faster. It would crack problems that are flat out impossible for a normal machine. Problems so tangled, so buried in probability, that an ordinary computer would need longer than the age of the universe just to begin. That machine has a name, a quantum computer. And in December 2024, Google announced it had built one that actually works. They called it Willow. Think about the device in your hand right now. It runs on bits, ones and zeros, on or off. Every photo, every message, every video you have ever sent got chopped into a river of ones and zeros racing through circuits. That's classical computing, and it is staggeringly powerful. But it hits a wall, a hard mathematical wall that no amount of engineering will ever punch through. Willow refuses to play by those rules. It runs on qubits, and a qubit will not pick a side. Thanks to something called superposition, it can be a 1 and a 0 at the same time, a smear of pure possibility hanging there, undecided, until the instant you look at it. That single trick pries open a space so vast, it makes the most powerful supercomputer on Earth look like a pocket calculator. And superposition is only half of it. The other half carries a name that made even Einstein deeply uncomfortable. It's called entanglement. Tangle 2 qubits together, and they form a bond that distance cannot break. Change one, and the other answers. Not after a signal races between them, but together, instantly, as if they were a single thing stretched across space. Einstein hated this. He called it spooky action at a distance and spent years trying to prove it couldn't be real. He lost. It's now one of the most tested, most confirmed effects in all of physics. Willow has 105 of these qubits, all running in superposition and entanglement at once. And here is what Google showed the world. They handed Willow a benchmark built to break any computer alive, and Willow finished it in under 5 minutes. The same problem, handed to the fastest ordinary supercomputer on the planet, would take longer than the universe has existed. Not a metaphor. Longer than the age of everything. That's the number everyone reported. That's the headline. But that number is not what made Hartmut Neven reach for a word he wasn't supposed to say. The thing the machine's creator actually said. Here's where the story stops being about speed and starts being about something you'll have a hard time shaking. Neven is not a hype man. Picture him for a second. A physicist who has spent years of his life building this exact machine, standing in a lab where Willow sits sealed inside a cooling system, chilled colder than deep space, because the qubits are so fragile that a whisper of heat destroys them. He runs one of the most advanced quantum labs on the planet, and when Willow's result came in, he didn't just clap and celebrate. He asked the dangerous question. Not how fast is it, but how is this even possible? Where is all that work actually getting done? A machine with only 105 qubits was behaving as if it had access to a staggering amount of computing power, far more than its own circuits. Sitting in that fridge in California should physically be able to hold. and a normal person shrugs and moves on. Neven couldn't, because the numbers didn't add up inside one universe. And the answer Neven gave out loud in public was this. He suggested Willow's performance lends credence to the idea that the computation is not happening in our universe alone, that the machine is, in some real sense, drawing on many parallel universes at the same time, that we live in a multiverse, and a quantum computer might be one of the only places where the seams of that larger reality briefly show through. Read that back slowly. The man who built the machine looked at his own creation and said the best explanation for how it works may be that other universes are real, and his machine is quietly borrowing from them. And he didn't pull this out of nowhere. He pinned it to a specific physicist, a man at Oxford named David Deutsch, who has argued for exactly this for decades. This is the moment. This is the thing that has everyone talking, not a press release. A working machine, and the scientists closest to it, admitting that the reason it works might be that reality is far bigger and far stranger than any of us are comfortable saying. And the obvious question is, could he possibly be right? Or is this a brilliant man talking himself into science fiction? If you're the kind of person who wants to know where a claim like that actually comes from, the real physics underneath it, not the clickbait version, this is exactly why this channel exists. Subscribe and stay with me, because I'm about to walk you straight into the idea Neven was pointing at, and it is one of the most serious, most divisive ideas in all of physics. It's also the part most videos get completely wrong. The many worlds. The idea has a name, the many worlds interpretation of quantum mechanics, and it did not start with Google, it started with a graduate student. In 1957, a young physicist named Hugh Everett wrote it down for the first time. For years it was treated as a curiosity, too weird to take seriously. Then David Deutsch, working out of Oxford, picked it up and refused to let it die. And you have to understand who Deutsch is. This is not a fringe figure shouting into the void. He is one of the founding fathers of quantum computing itself, the very field Neven now works in. The machines Google builds trace straight back to this man's ideas, and Deutsch will sit across from you, calm as anything, and tell you the many worlds are not a metaphor and not a thought experiment. They are simply, literally real. He has spent his life on that sentence. So, here's the idea, stripped down. Every time a quantum event happens, every time a particle drops out of that haze of possibility and settles into one definite state, the universe does not pick one outcome and throw the rest away. It splits. Every possible outcome happens, each in its own branch of reality, all of them just as real as the one you're living in. All of them running in parallel, none able to see the others. Now multiply that by every particle, every collision, every flicker of every atom in existence, happening constantly, everywhere. What you get is an endlessly branching tree of realities, all real, all running at once, and you sitting on exactly one branch of it, dead certain it's the only one. There's a version of you that put this video off until tomorrow, a version that never clicked at all, every one of them in this picture, just as real as the you watching right now. If that is true, and Deutsch will tell you to your face that it is, then a quantum computer is not just a fast calculator. It's a machine that gets its work done by quietly enlisting versions of itself in neighboring branches, running the calculation across all of them, and pulling the combined answer back into this one. That is what Neven was pointing at, not poetry, a literal description of what the machine might be doing every time it runs. And if your gut is screaming that this cannot possibly be right, good. You are in excellent company, because plenty of brilliant physicists think Neven went too far. Why serious people disagree? Let me be straight with you, because this is where the honest version splits from the hype. The many worlds interpretation is one way to read quantum mechanics. It is not the only way. Other physicists, just as sharp, just as credentialed, look at the exact same equations and see only one world, with the strangeness hiding somewhere else entirely. And here's the part almost nobody tells you. These rival views mostly predict the same experimental results. The math comes out identical. What changes is the story you tell about what the math means. So when a skeptic hears Willow computes across universes, their pushback is fair, and it's sharp. The machine working does not prove the other universes are there. It's consistent with them. It's also consistent with interpretations that never mention a single parallel world. Willow is jaw-dropping proof that quantum mechanics is real and usable. It is not by itself, a postcard from another reality. That's why Deutsch and the people in his camp don't argue from any one machine. They argue from a question you should sit with. If all that computation isn't happening somewhere, then where is it happening? Where is the work being done? Many worlds gives a concrete answer, however uncomfortable. The rival views answer differently, and nobody has closed the case. So, Willow didn't settle the argument. Willow did something almost more provocative. It took the argument out of the seminar room and bolted it to a real, humming machine that anyone can point to. And that machine now sits in the middle of a much older question. One that was already keeping physicists awake long before Google switched Willow on. The older question, this reopens. Here's why this particular claim from this particular machine hit such a nerve. It landed right on top of a suspicion that's been growing for years. That reality, at its deepest level, might look less like an accident and more like something built. Sit with a few facts. None of them came from Willow. Start with fine-tuning. The dials that run our universe, the strength of the forces, the masses of the particles, the energy of empty space, are set at values that look almost suspiciously perfect. Nudge several of them a hair, and atoms never form, stars never light, and nothing interesting ever exists. The physicist Paul Davies gave this puzzle a name that sticks: the Goldilocks Enigma. Not too hot, not too cold. A razor-thin band of settings where a universe can actually produce galaxies, chemistry, and you. Now add the strangest idea of all. In 2003, the philosopher Nick Bostrom laid out an argument that still unsettles people. He said at least one of three things must be true. Nearly every advanced civilization wipes itself out before it can simulate reality. Or nearly all of them choose never to. Or, and this is the one that gets under your skin, we are almost certainly living inside a simulation right now. His logic is brutally simple. If advanced civilizations run many realistic simulations packed with conscious minds, then simulated minds vastly outnumber real ones. And a mind picked at random, yours, is far more likely to be one of the simulated ones. And then there's Max Tegmark, who pushes it furthest. He argues that reality at rock bottom isn't just described by mathematics. It is mathematics, a pure mathematical structure, and existence is what that structure feels like from the inside, which turns who built the universe from a question for theologians into something that sounds a lot more like engineering. Now hear me clearly, because this is exactly where those other videos lie to you. Willow did not discover any of this. It did not scan the cosmos and hand back a blueprint. These are old, unsolved puzzles. What Neven's claim did was throw a live wire straight into the middle of them. What Willow is and what it is not. So let me draw the line hard, because the difference between a real story and a viral lie is right here. No quantum computer has proven a creator exists. None has confirmed we live in a simulation. None has handed anyone a message from a parallel world. Anyone telling you otherwise is selling something. Burn that into your memory before you scroll into the next video promising you the machine found God. What actually happened is smaller and somehow more disturbing. The scientist who built the most advanced quantum processor of its moment looked at how it works and concluded out loud that the best explanation might involve realities beyond our own. A serious, decades-old interpretation of physics, long shrugged off as a philosophy problem, suddenly had a real, superconducting machine standing behind it. And a question physicists usually keep behind closed doors spilled onto the front page, attached to a device you could walk up and touch. That is genuinely new, and you'd think that would be the unsettling part. It isn't. Because there's one detail about Willow that changes the stakes of everything I've just told you, and it's the part that should actually keep you up tonight. The part that should keep you up at night. Willow is not the finished machine. Sit with that. It's a prototype, a first draft, a proof that the idea holds and the engineering is real. And here is the one part of this whole story that isn't interpretation at all. It's hard, peer-reviewed fact. Google's headline achievement, published in the journal Nature, was about error correction. Qubits are fragile. Breathe on one wrong, and it collapses. For years, the nightmare was that adding more qubits would just add more errors, capping these machines forever. Willow did the opposite. As Google added qubits, the error rate went down, not up. That is the result that convinced the field this can actually be scaled. that the wall isn't there. So, the real question was never about Willow, it's about what comes next. Google's own roadmap points at machines with vastly more qubits than 105, future versions that would stand to Willow the way a modern supercomputer stands to an abacus. And that's the thought that should stop you cold. A 105-qubit prototype was enough to make its own creator start talking about parallel universes in public. So, what happens when the machine is 1,000 times bigger? What does he say then? What does anyone say? Nobody knows. And that not knowing might be the most electrifying thing in science right now. Why this moment matters. Step back with me for a second, because you are standing somewhere rare. For thousands of years, the biggest question, what is reality actually made of, belonged to religion and philosophy and nobody else. Then science clawed pieces of it onto solid ground. Darwin showed how staggering complexity could arise with no designer at the wheel. Einstein showed that space and time themselves bend and stretch. And every leap came from a new kind of lens. When Leeuwenhoek first aimed a crude microscope at a drop of water and saw it swarming with living things, the invisible world turned out to be richer than anyone dreamed. Every single time humanity built a sharper lens, reality came back stranger and bigger than expected. Never smaller, never duller, stranger. A quantum computer is a new kind of lens, not pointed at the very large or the very small, but at the very strange. The layer where solid matter dissolves into probability and the ordinary rules quit working. And the first real look through it produced not a comforting answer, but a genuinely destabilizing suggestion from the man who built it, that the thing works because reality is bigger than one world. Maybe Neven is right, and every quantum computation is a faint signal bleeding in from a multiverse. Maybe the skeptics are right, and the answer is something we haven't even named yet. Science has not decided. It may not decide in your lifetime. But we have built a machine strange enough to make the sharpest people in the room go quiet. So, here's the real question, and I actually want your answer below. If a 105-qubit prototype made its own creator talk about other universes, what happens when the machine is 1,000 times bigger? Drop your answer in the comments. I read them. And subscribe, because chasing exactly these questions, the real science under the strangest claims, is the entire point of this channel. The universe hasn't told us who or whether it was built, but for the first time, we've got an instrument strange enough to make the smartest people alive stop, go quiet, and wonder out loud. Stick around. It only gets stranger from here.